So as I said, I'll be talking about how to do performance engineering in Agile and DevOps. I work for a company called SoFi, or Social Finance, and we are an online financial services company doing all the sorts of things that you would expect of banks. A little bit more about me. I've been doing performance engineering for quite some time, e-commerce, financial, SaaS, consulting. But before I got into IT, I was a nuclear physicist. I did experiments in Japan detecting solar neutrinos, as well as accelerator experiments over in CERN and in the United States, looking for quark-gluon plasma and trying to understand more about the Big Bang. I also live on a farm. That's me on my tractor. I grow a lot of fruits and vegetables and can them to make jams and preserves and pickles and sell them at farmers markets and to my office mates. And I also have a woodworking business. That's one of the puzzles I make. I make home decor items, furniture, toys, and sell those online and at craft fairs as well. So I stay pretty busy. The traditional approach to doing performance engineering or performance testing in the standard waterfall way is you do all your development and testing, and then maybe you do some performance testing and you go into production. Or more likely, you do everything, you put it into production, you realize, oh, I've got a performance problem, maybe I should do some testing. So that doesn't work very well for a number of different reasons. There's a lot of technical challenges, but also fundamentally, I want you to think about, in this process, we are trying to test performance into the application. So we're just doing everything and then doing performance at the end and hoping that we are performant. There's different ways to think about it. And as I said, there's a lot of technical challenges in doing this type of approach to performance testing. Performance environments necessarily need to be very large scale, so they're very hard and expensive to maintain, and just getting code into there is an ongoing challenge. The data volumes that you need to deal with are quite large, again, expensive and hard to generate, hard to manage. And of course, in any type of automated testing, you have the scripts that you have to constantly maintain and update, and that's just a never-ending ordeal. So all of these things mean that you spend a lot of time trying to do your performance testing, and all of these challenges bring into question the reliability or the accuracy of your test results. So we need to start thinking about performance differently. And normally people will just categorize performance as one of those non-functional requirements, right? And that the very word itself is very strange. Non-functional literally means does not work. And so essentially what that ends up meaning is nobody works on it and you ignore it, and that really doesn't work very well for the customer. What you really need to do is start thinking about performance as a feature, because your customers or your users certainly do, right? Well, not a lot of customers will give you a 5-star rating in your app store because you're really, really fast, but there will be a lot of customers that give you a 1-star rating because you're really, really slow. And they're not hesitant to go onto social media, your Facebook page, Twitter, and just complain how slow your application is or your website is. So clearly performance really does matter to the customers. And if you're in e-commerce, you can see in this sort of canonical e-commerce conversion rate graph, this, as you get your load times increasing, your conversion rate decreases substantially, right? So again, this is the way people tell you that performance really matters to them. And as you start to think about performance as a feature, then you really understand, then it really becomes clear that everyone has a responsibility for performance. It's not just performance engineers or QA engineers. And with everyone, as a feature, it's important to your customers, it's important for everyone to think about it. It means you really need to think about performance throughout the entire life cycle of your product or your application. So what does that look like? And again, now we're not just thinking about performance and testing, we're thinking performance all the way at the beginning, even when you're in the realm of business or marketing. So everyone is, every company is generally trying to grow. That means increasing usage, increasing customers. You've got to start thinking about, that growth and what do your growth projections look like? And what does that mean for your scalability? And marketing campaigns are especially tricky. And even recently I got dinged by a campaign. We decided to purchase the naming rights to a American football stadium. So that has a very huge audience. The marketing team was very unclear about that this was going to happen. We got a couple, like 4 hours notice. Oh, hey, by the way, we're making this huge announcement. Millions of people in the United States are going to see it, and they're probably going to all go to our webpage. So we did some testing. We kind of, it didn't go very well, or we thought it went well. The marketing campaign launched and our site went down. I'll talk more about exactly why it went down. But it turned out that, not only did we only get a few hours notice, but they actually didn't even tell us the entire campaign. It wasn't the announcement of the naming that brought us down, but it was all the commercials that we put on television throughout the day that we didn't even know were coming. So, definitely, again, right, we need to think about performance and scalability, very, very early on. And as you get into your plan, and then again, with this in mind, as you start planning out your products, planning out your development, be thinking about your SLAs. And this is really important. Again, don't let it come at the end. I had an experience where I was, we were testing a page. This was a product page, very important page. And the testing found that the load times of the page increased by half a second. So we said, if you think about that curve I showed earlier, a half a second, not a good, not very desirable. So we said, well, this can't go live into production. The product owner came and said, oh, I want this product live. I've got a date, I've got a target, I want it live. We said, well, it doesn't meet our SLA. You're not going live. And he said, well, how bad is it? I said, it adds a half a second to the page load time. He said, well, half a second doesn't sound that bad. I'm okay with that. I'm the product owner. Go live. I need to hit this target date. And again, I said, no, it's not within our SLA. You're not going live. And he challenged and said, what, who are you? You're just a performance architect. You're just the performance team. I'm the product owner. I make the decisions. It's going live. So I showed him that graph and I said, you're right, I'm nobody, but here's our customers telling us what the SLA is, and they will not accept a slower page. So you're the product owner. If you want to put your page in half a second slower and cost us millions of dollars, go right ahead, right? So obviously it didn't go live. We fixed it and it went live, in a week or so, but having this conversation about SLAs early, is very good, and being aware of that. And then as you get, another common question or challenge is there's no way you can do performance in Agile, right? Because again, performance testing has to come at the end. And Agile is really fast. Performance testing by nature is really slow. You can't do Agile. Therefore, you can't do Agile performance, right? Well, you can, obviously that's not true. There's many ways to integrate performance engineering into the Agile process. I was working with a team and again, they said, well, they were just starting Agile and they said, well, we're just starting Agile. We barely know what we're doing. To think about performance testing, Gopal, you're just a dreamer. You're just an architect. This is real life. Come on, we can't do performance testing in Agile. I said, well, let's start small. When Agile, definition of done is really, really important. So I said, let's include the definition of done into your Agile or let's include performance testing into your Agile definition of done, in which case they said again, well, that's too complicated, we can't performance test everything. I said, no, we're not talking about performance testing, we're talking about performance engineering. And let's just start by making sure that every single story that you have, you think about, is there a performance impact to it, right? That's the a major step. So they agreed, okay, we can do that, right? We can think about whether a story has performance impact. So I worked with their Jira, we were using Jira. I worked with their Jira admins and we added a little checkbox into every story, check, thought about performance impact or not. And when there was a performance impact, then we went ahead and created stories in Jira to handle all the performance engineering activities. And this has a lot of benefits because it integrates it into part of the sprint. It makes it part of the sprint planning, the sprint grooming, the sprint retrospective, right? You just bring it in, and again, instead of just making it something that comes afterward that the team hands off, integrate it all, integrate it into everything. And again, performance engineering is not just about testing. When you get into production, you need to have a lot of monitoring. You can start creating those monitoring, create the stories for those right in your sprint and get them part of your work. Design, now this is very important. Think about scalability. Think about things like horizontal scaling, implementing load balancing. Think about caching. Caching is something very easy, but I'm always surprised with how often people like to hammer their database to get static data or serve static JPEG images off their web servers instead of implementing a CDN. And that, by the way, is how our page our website failed when we did that stadium naming announcement. There was an oversight, and our CDN wasn't configured correctly, and we weren't caching any assets. So everything went back down to origin and brought our web servers down. And think about testability in your design as well. Testing, again, should not come as an afterthought, but make it, there's no reason, and I really think that one of the attributes of software should be that it is testable, easy to test. So again, like, when you're, especially when you're doing automation testing, or performance testing, managing data is very hard, or getting those scripts written is very hard. There's no reason you can't, make your code easy to interface or interact with your automation tools or your performance testing tools. And things too, like I'll talk a little bit about testing in production. There's a lot of challenges in testing in production, but if you actually designed your code to allow it to test in production, to be able to identify test transactions and handle them appropriately, it becomes actually very easy. But this is things, again, that's hard to do at the end. It's much easier to do in the beginning. And as you build, observability is very important. You want to be able to collect useful information out of your site, out of your applications while it's running. I'm always surprised. Just simple things like a good naming convention can help. I've worked on sites where every single page has, basically every single URL and every single page has essentially the same name, or every service call has the same name. So you can never tell exactly what the users are doing. It just looks like they do the same thing over and over again. And of course, when you're trying to understand your user workflows, get some metrics, troubleshoot, it's very hard when your logs just show the users do everything the same. And resiliency is something that isn't thought about very often. I know there's some talks about chaos engineering coming up tomorrow, but there's a lot you can do to just better handle failures. And simple things, I worked at a company where they just left the default timeouts of like 5 minutes, I think, on the web servers. So things, whenever anything slowed down, every application just, all its threads started to wait. It became thread starved, and the whole thing would lock up. Just simple things. A funny story there. So where I was really pushing, you've got to set good timeouts. Nothing longer than 30 seconds, but as short as possible. So we deployed a page, and all of a sudden, immediately upon deployment, that page just got 30 seconds slower. and took us a while to figure out it's just exactly like plus 30 seconds. Well, we finally realized that the developer had, instead of putting in a 30-second timeout, he put a 30-second wait into the code. So at least it was an easy fix. Just think about how you can handle failures. And eventually, you'll, you're doing Agile, you're going to want to do CI/CD testing. And again, the question, how can you do performance testing in CI/CD, right? Because performance tests are big, they're long, they're slow. Well, think about a different type of performance test, one that's very, very fast and just focused on a few key metrics. It's not a scalability test, it's just a performance test where you're really establishing baselines of your code, running a few transactions against it. Do not use average. Average is very bad, especially average is always bad for performance, but we can, if there's questions around that, we can talk about it. But you want to use like a 50th percentile, and it's much more accurate. But then you can in addition to thinking about response times, you can also look at other metrics like counts, like how many calls to third-party services are you making? How many calls to the database are you making? Because these things can changes in these counts and these call numbers can have huge impacts to performance and scalability across your entire architecture. And they're very easy to catch if you're looking for them, and you can do them in CI/CD. Catch these big issues and let smaller issues through that you can handle quickly. When you're trying to test very fast and do this analysis, it's very helpful if you can build a framework to make it very easy to do this testing. There's a number of different open source and off-the-shelf or commercial products out there. JMeter is a big, JMeter and Gatling are big open source testing tools. Of course, you can use something like a GitLab pipeline or Jenkins to orchestrate, integrate with your APM tools like Dynatrace or Datadog or anyway, some other ones. They're all they're all out there, and then have some and then have a way to analyze it very quickly. You can also use tools like Elastic or Splunk to help with that. And then, do your CI/CD testing, your small-scale testing. There is still a place for laboratory or large perf environment testing, but it's changing now the attitude of, don't try to test everything. The reality is that 99.999, at least 3 nines of your check-ins, of your code commits are not going to have any performance impact. So don't try to test them. It's just kind of a waste of time and money. But what you do want to test in this type of way is your major architectural changes, right? Like, okay, you're changing your framework, you're changing your database, you're changing a database driver, you're introducing a new service or a new application, or you're trying to test for your unique events, like like in the United States we have Black Friday and Cyber Monday, or we have you might have big sale announcements, you might have big registration events, or all your customers are coming, or all your users are making some choices or having to register. These are types of things which it is challenging to prepare for if you can't test in an experimental way beforehand. And I'm also a very big fan of testing in production. It's really great because your test environment's perfect. It's 100% accurate. You do, in most cases, have like free test scripts and test users. Your customers, they kind of pay you to test. And there's a lot of different ways you can do it safely. You're familiar with like an A/B or blue-green deployment, or a gradual rollout where you redirect like 5% of your users or 1% of your users, see how it goes, and then ramp up 10%, 50%, and eventually up to 100%. Where you're gathering metrics and information all the time. It's also a great place to do synthetic load testing, again, because your test environment is perfect as you could want it. But as I said, it's important to design your code for that. So I was at an e-commerce website, And we wanted to test for Cyber Monday, which is our biggest sale day of the year. So we actually put code in that could recognize a test transaction and route it appropriately so that we never actually, shipped items out anywhere. It never went to our inventory management system. And we were able to actually, when I first said, hey, let's do performance testing in production, management thought I was crazy. They just looked at me like, you're crazy. We might just fire you right here and now for being unreliable. But we got to the point, over very, very careful testing, where we were running Cyber Monday load, which is our peak load of the year, twice a week in production without any issues. So it was very, very, and we found actually a lot of issues that we couldn't have found otherwise because we were literally testing in production. And then browser testing is very, very hard. I think there was a talk earlier today that talked about how to do browser testing. It's very, very hard in any case. And so you can do something called real user monitoring or real user testing, or browser testing, where you can collect those browser performance metrics from all your customers or all your users right in production. It can be very, very effective if you can react fast enough. And of course, you never will be able to or should be able to test everything, but you really need to monitor everything. So this is, beyond just testing. You're in production. You need to monitor what's important, and that's the customer experience. It's going beyond just CPU and memory utilization monitoring, and think about, what are your customers seeing, and how is that affecting their behavior, and what does that mean to the business, right? So metrics like how many orders are you placing, how many reports are your users completing, how many accounts are they opening, right? Things like this, you won't see from CPU and memory. I've seen a lot of failures where a system is down, users can't do anything. CPU is like 5% utilization, right? It's like perfect. Right? If you're only looking at CPU. So make sure you monitor what your customers are doing. Obviously you need dashboards to do that. And then here's like the very simple formula for creating alerts. Look at your production. Look at kind of like what your peak level is for like your CPU or memory or something. Set your alert threshold just a little bit above that. You should be okay. Enable your alert. Then go into your email and set up a rule to delete all the alerts that you're going to get. So maybe some of you have had this experience, but setting alerts is kind of more of an art than a science. But there are some really interesting machine learning applications now, which can help you dynamically manage those alerts. So if you haven't checked those out, a lot of the tool vendors are putting them in. It's definitely a good thing to look at. So I've talked about how to do performance engineering in an Agile environment. I want to talk a little bit about how to do performance engineering in an Agile way. So the big thing when I think about Agile, one of the Agile themes is individuals and interactions over processes and tools. So typically when teams implement Agile, they think Agile is this, right? You have to do Scrum, and you have to use all these terminology, and you have to do product planning, and you have to do this, and you have to do that, and you do all these things, and you're doing Agile. But don't be like an Agile zombie. There are different ways to approach Agile. So when should you do Scrum? Now, this is not for development. I'm only talking about performance engineering. When is Scrum applicable? It's when your performance engineering team is strongly aligned with a development team that's doing Scrum. So if you're in an enterprise-wide engineering team, this may not be the case. But if you can align with your development teams, go ahead and do it, because then you get very predictable planned work, and then all the Scrum type approaches really work well. If your company or your team is new to Agile, Scrum is also a little bit more friendly. But there's still a lot of ways you can go wrong with Scrum. I found a lot of success in using Kanban. Why? Because when a lot of times as an enterprise performance engineering team, you're not aligned with development teams. So like currently I work with about 50 different development teams, and they're all on their own schedule. So my workload is very unpredictable. If I was to have sprints that start and stop on specific dates and I have to go through all that process planning, it wouldn't work very well. So now stuff can just come in, and based on the priorities, we can just start working it or push it into our backlog. We don't really need a lot of planning and go through all those Scrum ceremonies, because we always do the same work, right? With performance engineering, we meet with them, we come up with an approach, we update the scripts, we execute the test, we analyze it, and then we're done, right? We don't need to, fingers and voting and t-shirt sizing. They have their place, but think about if you really need to go through all of that. It's very important to manage your backlog, especially in Scrum. I always think of the backlog as like a black hole. You put stuff in there, it never comes out, and it just gets bigger and bigger and bigger. So be very careful about, don't use your backlog as a dumping ground. And be very, very careful about managing your WIP, or your work in progress. So one way to manage your WIP is another different technique. How many of you are familiar with like a hackathon? So first hackathon I did a few years ago, and I was just really like blown away with, really impressed with how this team was just able to come together, really focus, and accomplish a lot of work. So I thought to myself, well, what if I did hackathons not just once a quarter or once a year, but what if I did it like almost all the time or a few times a week? And so I started calling them perfathons, and we started just doing that, where the team would just come together, take a problem, and work on it, intensely and get it done. And that's actually, an official work, or a recognized work method. It's called swarming or mobbing, where it's completely different than what a lot of people are used to. Instead of what's the word? I can't think of the word now, but instead of divide and conquer, it's combine and conquer. And this is really great too when you have a geographically diverse team. Like currently I have a team spread out across North America as well as Europe. And so it's a way for us to all come together and work together and combine our varied expertise and background levels, and get things done very, very quickly. As well as train and share the knowledge. And this is something that takes a little bit of practice. Give it a chance if you want to try it. Again, like it seems sort of counterintuitive, but it can really work when applied appropriately. And again, think about like a hackathon, which is a very familiar approach. And a little bit about putting together a performance engineering team. This is kind of what I've sort of settled on. You have an architect that provides that technical leadership and vision, and does some of the TPM or technical project management work, engages across the enterprise. That's usually, of course, I always have one because that's me, so I can't really be on a team without that happening, but I think that role is important. You've got the performance engineers, which are really focused on analysis. Data analysis is the key skill for performance engineering, as well as the other things. It's really great if you have a manager handle all the HR stuff and the politics, because that's really no fun for all the technical folks. And if you're managing a test environment, or you're developing tools and frameworks, having a DevOps type role can be very useful. I haven't seen a lot of success in bringing developers into performance engineering teams long term. I've done it a few times. They always get bored and they start like coding crazy stuff, and then they leave and we throw it away. So I haven't seen that very well. And then QA, performance engineering is not like test. It's not the same as functional testing. So it can be challenging for people who really like QA testing to transfer over into performance engineering, because the primary skill is the results analysis, not actually the testing. And so, so I've you're all here because you're interested about performance, but I recognize that not everyone in your companies, when you go back, are going to be so interested. So, and part of that is, their prioritized responsibilities. They've got to do all this stuff, and and then you go back, you say, we've got to think about performance. They're like, I don't know. So, if you want to be able to influence people at your company, it's really about educating and enabling them in performance. And when a key way to do that is keep score, present interesting metrics, present reports that are relevant to the teams and relevant to the business. When teams don't even know what the performance is, they're not going to be very interested. But as soon as they know, it's now, it's in front of everyone. It's data-based decisioning. But make sure you target the right teams. Not every team, not every application, not every product, not every service does performance matter. So if you have a web page that just displays like your company's locations and hours, or your store locations and hours, maybe that's not really so important for performance. Whereas like a home page or a product page, a login page is. So if you focus on the right teams, you will get much better traction and get much better results. When you do, and when you start focusing on them, you really have to get in there and get hands-on. You can't just stay off and be like a ivory tower theoretical center of excellence. You really have to be able to do work. That's what really gets things going. So start by writing their scripts, run their tests for them, show them how to analyze it. And then eventually train them how to do it, train them on the tools, and then hand off to them. But just telling people to you should do performance, I haven't seen a lot of effect with that. But saying you should do performance and we're going to get you started and write all your scripts and execute your tests works very well. And when you have successes or when you have failures, write them up. And so this provides a good medium for you to share them. A couple things. One is, you're working with a little team, or you're working with one team. You need to spread out, both all your findings and your lessons learned to the other teams, as well as advertise your services or what you can do or why performance is important and what you've accomplished. It's also important. There's always a lot of turnover in most companies in IT, and I constantly think like, okay, I've worked with every team now. I'm very successful. Everyone knows about performance, and they're really excited about it. Well, new people come in and they've never even heard of the performance or performance engineering. And so this is a good way to sort of embed it into the culture, have some cultural assets that you can indoctrinate new people in. And so if you just have a few takeaways from this talk, think of performance as a feature and think about performance across your entire life cycle. Thank you.